Welcome. This is a blogging system using Next.js Redux and Strapi version 4 as a backend. This is actually part of a much larger project. So before I get into functionality, let me just show you. This is the Strapi backend, the post collection, categories, comments, etc. And this is the Strapi backend log. Now let's get to the functionality. First, let's start here, pagination, and then let's try to filter by React.js, which is a category, then narrow it down further by choosing featured only. And now let's filter more by tags, which are here, and it narrows it down to what we need. And if you want to start over, just hit this button, it resets everything. And now let's see what we can search here. Let's try a simple one first, SCSS. All right, look, here, here, here. So that means our search is not only limited to the title, content, it also includes categories and tags. This is basically a full text search mechanism based on Strapi API. Now let's try a larger piece here from the title here, copy that, bring it here, enter. All right. So now as we can see, very visibly from the title, this same text is available here. We know that these two came out of that search, the search text, but this one and this one, not so much. So let's go in and let me do a Control F here, and look, that same search text contains in the content. Now that we're here, let's see, we have a commenting option. We're also listing the comments by users' profile images, names, etc. Now let's see what happens when I click here. Immediately tells me to log in. So let's sign in, and boom. As soon as we do, we get a comment text box where we can actually leave a comment. Free post immediately shows up, and we also see a delete button being visible right beside the person who is currently logged in. Now let's delete one, and we successfully do. And if we sign out, that option goes away. And one more thing, when we don't have any comment, we simply get no comments found. And that being said, let's go to a diagram where we can learn about the architecture of this application. All right, this time I wanted to break it down into two different blocks, one backend framework and the other one is front-end state management. So right now, we're just going to focus on the backend framework. Here we have our Strapi backend, and in here under the services, I have a few services to connect to that. One is a generic API client, which will have a bunch of environment variables like API keys, URLs, etc. And then I use Axios to create a module that I can reuse everywhere. And then I have this HTTP service going where I declare a generic types depending on the Strapi collection results, and declare some generic functions like get all, get one by ID, get one by slug, etc. And then in here, post service, this is where I get to be specific. This is where I actually provide the real URL like /post. If you want to get post, go to /post, and then provide the data structure or the type in here. So this gives me a sort of a pattern where, let's say if you have multiple collections you're accessing, like comments and then user reviews, then restaurants, etc. So in that case, you can just keep replicating this guy and provide specific information on that, and connect to these generic modules to connect to Strapi backend. And we'll get into much more detail when we look at the code. So with these generics, I have a data layer. In this data layer, I have two files for each collection. For example, for post.ts, this will have all the API methods, like actually getting all the posts, getting a post by ID, etc., by calling this post service and utilizing these generics. And I also have a post entities, which will have the TypeScript types, basically the data structure that describes this post. And for each collection, you can have just these two files, replicate them and change them accordingly, and then put them all in this index file, which will have the data source, a single data source that will encapsulate all the collections that you are going to be dealing with as far as Strapi goes. And then once these methods are created, then I can just call them from, let's say, my blog index file and slug.tsx, which is basically responsible for all the single pages. So in here, in the static prop, I'm going to be calling the function getPost using that data source. And that's how I'm going to be collecting those static data during build time. That will help me with the SSG, or static site generation. And same way in here, besides using get static props and like functions like get post by slug, etc., I also have get static paths, where I get all the slugs in a string array and then put them through a loop to create all the static paths for all the posts, so that after build time, once again, SSG, static site generation, happens. And after deployment, you might say, what happens when somebody adds a new post, right? Because since we have all the static paths and the static files generated during build time, what happens after deployment? To answer to that, revalidate comes in, and that provides us with ISR, which is incremental static regeneration. This is how Next.js keeps the site data up to date and fresh. Now let's go to the code. All right, so we are back at the code. So let's first go to services folder and check out the Strapi client. This is, as mentioned before, this is collecting the URLs, API keys, etc. from the .env file and passing those along to Axios to create a portable client. And this is the client that I can use pretty much everywhere in the application to communicate with Strapi. Let's start with HTTP service. This is the same client I'm bringing in. And here I am defining the data structure, the generic data structure of pretty much all Strapi collection responses. To prove to you, let me go back to the data. Let's say here, right? I mean, if I want to bring in all the posts, I refresh, I get this. And if I try to find the actual structure, it gives us this. Pretty much all the collection array comes like this. There will be a data attribute, and that will have an object array. That's where all the data is. And then there will be meta. Meta would have the pagination information, whole bunch of numeric attributes. So you look at this structure. Now let's go look at here. See right here, I declare the pagination, and then I create this generic API response with a generic variable t, and give it a t array, and then pagination brings in pagination, and there you have it. We have our collection data structure and the generic one. So no matter whether you're bringing post data, comments data, or let's say any other collection you may have, like categories, they will all come in this format. And accordingly, I have the single response also, where I just get just the t, just the object as data. And as you can see here, if I come here, okay, let's change this to ID4. Oh, this is the base structure of a single piece of data. We're going to have an ID and attribute. And inside the attributes, we're going to have the actual object with all the details. So now, if we look here, the single one, we just declare an object. So no matter what the object structure is, these generics are going to help us. And later on, when we actually go to like more specific ones like post services or comment services or whatsoever, this is where we're going to declare the nature of the object. We're going to get more specific. But for this one, we want to keep it completely generic. So I declare a class here, HTTP service, and put my generic type in there. And in the constructor, we're receiving a string, which would give us the actual location, the URL location of the data source, which is Strapi. For example, from the client, Strapi client, we're going to get the URL source, but from here, we're going to know whether it's /post or /comment or anything else. And it's going to get more clear once we go to the post service. But before we go, let's look at these generic methods. Get all, get one by slug, get one by ID. And each time we are passing along a query attribute as a string. And this is going to come from our data layer right there. As you can see here, this data layer will supply us with all the necessary details to go to the actual source. That said, let's look into post service. It's a simple one, small one. This is where we're bringing in the post data, which is the actual structure is coming from data layer post entries. Remember, this is where we had two files for each collection. Post, that's where we're going to have all the methods. And this is where we're going to have all the data types and data structure. So that's where we're getting post data. And this is the constructor-based URL or string I was showing before, /posts. This is where we're going to provide other ones. Let's say if this is a comment, that will be /comments. If this is categories, /categories, etc. At this point, this is going to have the specific data structure declared. So now let's go check the data layer, post entries, and this is where all the necessary data structure are implemented. And as you can see, you have tag data, category, etc., everything here. But this is only representing the post data, right? Just to show you how this happened, let's go to our backend. And if we come here, let's say go to post. And if we open one post up, we see that we have post tags here, categories here, comments here, etc., right? But these are all separate collections. So this is happening via the content type post. And as you can see here, even though they are collections, they all have relationship with our post. This is one to many, and let's say this is many to many, and also many to many. So this is how all those data are being included inside one post. So if I just bring in post, I'm going to have related categories, tags, comments, etc., right? And also, if I look into this single piece of content, like basically the post, we can also see right there, see comment, categories, post tags. Everything is coming in with one call. And that's the reason this post data structure will have all the necessary details, and that will dictate how we are going to get our data intact and display onto the front end. And also here we have a post data source, and this is where I'm declaring the types of all the functions that I'm going to be declaring in this file. As you can see, get post, get slugs, get post by slug, get post by ID, etc. And how these are happening, if I open that up, remember with each request we were passing a query to the generic, right? So basically this post service is going to go talk to this generic HTTP service, but since this is post service, this will have the collection specific data or type included in it. So through this, Strapi will know what result to send us and to filter the information or populate with all these, let's say, as we saw, comments, categories, everything, it's going to happen via this query. This is the QS-based string that we're sending to our generic HTTP service to get the necessary collection data. And we can also take a look at get post slugs. Here, this is only returning a array of slugs. And remember, we need this for this purpose, to create the static paths for every single post by slugs, so that during build time, we can create static pages. And that is SSG or static site generation. Also, get post by slug, same QS query, so on and so forth. Now let's go take a look at our pages blog, and now we are at the front end, index.tsx. Right here, we're bringing in blog page content, post response API from post service, data source from data layer. Now, this is something we need to go back to our data layer to explain, because we skipped one little part, which is this index file. See, this is where we can create this whole thing into a repetitive pattern. This is where we, combine or centralize all our collection information. So each time we need something, let's say comment, so we're going to have comment.ts and then comment-entities.ts. We need categories. We're going to have 2 files, just like that. And from those, we're going to bring in all the methods like that and call it Strapi post API because of the post. And if it was comment, then we would call it Strapi comment API. So we just keep attaching stuff to it. And then from the entities file, the post data source, remember where we declared all those functions. So what we do is we declare an interface data source, which becomes our main type of our data source, and we just keep extending it like this: post data source, comment data source, so on and so forth. I mean, I know for a single a tiny module like this may look like overkill, but as I mentioned before, this is part of a larger application. Just to show you that this can actually get large and how it looks like, let me take you to my larger project that this will become a part of soon, right here. See, this is the similar data layer index file, but at this point, I'm bringing in restaurant, cuisines, and then cuisine entities, and then restaurant entities, and then we are just extending the data types for our data source, and then we're declaring our data source and putting and spreading all the methods in here, so that anytime from anywhere we just call the data source dot get tag, get data by tag, etc., etc. All those functions are going to be included here. Once that logging system is finished, that is also going to come and be attached to this project just like this. And that's what makes this a data fetching framework, which is a repeatable pattern that can be used to create larger applications, just like this. You just keep adding stuff to it and use your generics to go to your data source. And this way, what happens is, sometimes if you decide to change your entire data source, then all you have to do is make some changes here, and that's pretty much it. Your front end completely remains untouched or modular, so that you have great flexibility. And lastly here, let's go back to our other page, which is the single page. And this is where we're doing the similar things, getting the data using get static paths, data source dot get post slugs, and then mapping through that slug, we are creating the single post pages by slug at build time. And then with the get static props, we're just collecting that slug from the context.param, which is basically, if you look at here, if I go to a single page, look, it has nothing but the slug here, right? And this is the parameter we're collecting here and passing it to data source.get post by slug and getting our post data, just like this. I mean, here I'm using ID, but what you saw there was, instead of ID, we used the post slug. Pretty much the same thing. And we just return the post as the prop, and we set revalidate to 5 seconds. And this is how Next.js implements ISR, or incremental static regeneration. And that's how our project stays up to date beyond the build process and the deployment. That said, time to move to the next step, which is the front-end state management with Redux. All right, now let's talk about front-end and Redux. The story actually begins here. As you can see, in the main index file, once we get our posts, the static information during build time, we immediately call this component, blog page content, and we send a prop called initial posts and pass that static post data through it. And this is where the handoff happens. All right, so let's go back to that. So this is our blog page content. So here we are actually getting that initial post right here. So before that, we are actually collecting these filters and posts from the Redux store. And the store looks like this. This time it's /feature/post. I'm saying this time because on the previous video of this playlist, I talked about how authentication works, and that was under features/auth. So here, this time, I want to talk about the posts. Here we're going to have two slices. As usual, we're going to have the initial states. This is going to have a post array, status, published or not. And here the data setting functions, just like useState, we're setting the, all the posts here and set status. And the filter slice, and this is where we're describing all the filters like search term, is featured, category terms, post tag terms, etc. And we're including the pagination information, current page, and posts per page. And if you're wondering what these are basically these guys. All the filters and the feature button, search, all that are here. And this is where we give them their initial state, and then we use these functions to change those states. Set search term, toggle featured, add category, remove category. Why add category, remove category? Because see, this is how we're adding them, and then removing them, right? Same with the tags also. So what we need here is two functionalities, adding the state and removing the state. So that's what these functions are doing. And reset all is resetting everything. And that's the button in the upper right hand corner does. Once we hit it, it resets everything, brings everything back to normal. And then we have the API posts. This is the one makes the call to our Next.js backend. And I'm calling it API/post search. And here we're going to give the filters as an attribute. And we get these two hooks back. And once we implement these hooks, this guy contacts this guy, and eventually this guy talks to the data layer, uses these functions to talk to Strapi. This guy is same as this guy, avoiding this, bringing in the services just for simplification's sake. Now let's see what happens here. Remember the handoff we talked about? So here we're bringing in the filters from here, the initial state, and we're invoking this use get posts query here to get the post and sending these filters through. And at this point, these posts are empty. This has nothing. And that's why we bring in a use effect and call in that set post and pass that initial post that we just got from our previous page, which is the index page. Remember here, we collected all the post information and sent initial post as a prop. And this is where we hand it off to Redux using set post, and set post comes from here, post slice. And once we go to the code, you will see that we implement some further filtering mechanism. And now that we have data in our Redux, that's when we augment that filtering features. And this guy is connected to search form, switch button, checkbox, group categories, checkbox, group tags, etc. Let me show you where they are. This is the switch button, the category group, the tag group, search form. All these components will now have the ability to change those filters. And once these filters keep changing, our API post here will keep making the call to the backend and update the data in our front end using this post. As you can see here in our search form, we will use set search term to update the state. Switch button will have toggle is featured to update the Boolean status, add category terms, remove category terms, add post tag terms, remove post tag terms. And these are the guys who help us change those category and tags. That said, let's go to the code. All right, so here I have everything side by side. So this is our main index file. This is where we did all the static generation and then called in the blog page content, initial post. We're sending all the posts that we collected from here. And this is where it actually happens. See, we're getting that initial post. And now we're using these filters. Use select from the state.post filters. Where are the filters? These guys right here. All the initial state that was declared, they're coming right in as filters. And then we are calling this use get post query. And this is coming from API post. This is where we are declaring one function, get post. And we have our query here passing the filters. And according to the filters, we are building our whole query, starting at post search. Remember here, we were going to call at the post search at the Next.js backend, and that's exactly what's happening. At the post search, we are just augmenting it if there is a search term available, if there is featured, category terms, post terms, current page information, which will help us with pagination. So with all that being done, we are returning a query, and that query is going to go make a get request to actually post search, and that guy is pages API post search. It's a simple little file, but this is where all the filters and stuff comes in as a query, and then we call data source.search post, and this guy makes the call to our backend here to our data source, and that method is sitting right here in the post.ts, and that guy makes the call to Strapi, and we get the results. All right, so let's go back to the blog page content. Let's see what's happening here. This API post is giving us two different hooks, use get post queries and then use lazy get post query, and you'll see why. So initially, we're going to use this here to get our Redux posts in the mix, and then we will update it right here inside a use effect. But immediately afterwards, we need to bring in the same function, use it inside another use effect with some if-then logic. And you know that we cannot use hooks inside use effect or if-then logic, right? So that's why graciously Redux gives us use lazy get post query. So with this, it actually gives us the function out. I mean, instead of getting the data straight, we're getting the function, and this function now we can use inside a use effect, if then logic, etc., etc. That being said, so here we are, since we are already updating our post right here at the first load, so second load, we don't want to do it again with filters, but we do need that where filters is a dependency, because we do need to call it whenever there is a slight change to the filter. Anytime user makes any update to that sidebar, choosing a category or a tag or putting in a search text and hitting enter, that changes the filter. And by having this use effect, every time there's a filter change, you're going to make a get post call with that filter change, and thus it creates an update like that every time. And that's why we had to bring in this initial mount.current. We are just declaring a ref here, initial mount. So we're just going to check for the initial mount. If it is current, that means the first load, we're just going to turn it into false. That means at the first load, it will never touch this. It's going to skip it. And then either from a second load or any kind of change on the filter state, whenever that happens, this is going to be called, because filters is a dependency. And this, my friend, actually completes the data handoff from our initial post to Redux. And thus, we get to do all sorts of filtering using these kind of functions. And now that we come this far, let me just quickly show you how the store is working. I have showed this last time and explained in detail in my previous video of the list, but this time I'm just going to quickly go over the code so that you know exactly what I'm talking about. This is the store. We're still using the persist config and whitelisting auth, because with this Redux persist, we are persisting the authentication data into our local storage of the browser. But that's not important right now. What's important here is our root reducer combined everything. The API posts, I have auth, I have comments, etc., etc. But here, two things are important, because I will show you later how this API comments work. And this time, and right now, I'm showing you the API posts. So right there they are, and also the post slice, the comment slice, and the post filter slice are right here. And then after declaring the middleware and taking care of the persist information and taking care of the persist stuff, we just concatenate our middleware like that. API posts.middleware, API comments.middleware, and then we just export persister. And with that, we go back to pages and look into our app.tsx. As you can see, the provider is right there, provider coming from React Redux, and we're passing along the store. Store is coming from our store, and persister is coming. So now we need one extra thing that's just for the authentication, persist gate, coming from that same library, Redux persist, and we are passing that persister in there and also wrapping the whole thing with it. That's why our authentication now persists in our local storage. This I had to show. Next, let's just look at these components to see how they are updating the status, how they are updating the state using Redux. All right, let's start at search form. So initially we're bringing dispatch, and then we're declaring an input value. And right here, it's a very simple component, a form. On submit, we're just doing this e.prevent default so that it doesn't refresh the whole application. And then here on change, we're calling one function handle search, and then key up handle search submit, mainly because we are invoking it when somebody hits the enter key, right? So that's why we're bringing in on key up. So let's see what handle search is doing. Handle search is basically updating the input value with e.target.value, and then handle search is looking for e.key. If this is enter, then it's going ahead and dispatching the set current page, setting it to 1, and dispatch search term to input value. And that is updating the overall filter object, which is kicking off a request to the back. And why we are updating the current page? Because what happens is, let's say if you are somehow in the second page and then you do something like this and it comes down to 2, right? So without updating the page number to 1, it will never come back to 1. It would just stay there at 2, and you're going to get an empty screen. And for that reason, it's always important to set the current page to 1. And that's why this current page, post per page, etc., these numbers also part of the filter. And here we're updating the search term. Now let's go look at switch button. All right, so this is a simple one. Here we are once again invoking dispatch because we want to invoke some of those toggle functions right here. And this is what the switch button looks like. And this is what it depends on, the enabled, which is a boolean. And this one we're getting from state.postFilters is featured. So if is featured is true, it will change one way, and if it is not, it will turn on. And if it is not, if it is false, then it will turn off. And that's how everything is set. All the Tailwind classes are set that way. Label text right here. And it's simply the handle change on the on change is basically just once again setting the current page to 1 and dispatching the toggle is featured, which updates the is featured to true or false. And as soon as this changes, that also triggers a filter change, and filter change makes another call to the backend happen. Now let's look into the checkbox group. Here I'm just hard coding it. These are supposed to be the categories, calling it a framework options right here. By mapping through it, I'm just creating the whole component. And this handle change category select, this is the main function. This is collecting the value and checked information from e.target, and thus it is updating the current page to 1. And if this is checked, then it is invoking that add category term value. Otherwise is remove category term value. And we know these functions are right here: add category term, remove category term, add post term. And the same way, checkbox group post tags is doing exactly the same thing. It looks exactly the same, just few things renamed, and it does everything exactly the same. That said, let's next look at the commenting functionality, how we're doing that via Redux. This is the part we're going to talk about now. This component is called the comment list, and this is called the comment form. And we're also going to get our Redux module involved here, which is API comments. Let's look at this one first. So far I have shown you the ones that are involved with the get process. They only get the data, but here it's a bit different. We have two of them. One is involving the post, which is creating the comment, and other one is calling the delete method to delete the comment, right? So that's how these are fashioned, and they no longer give you like a get post query, something like that. They give you use create comment mutation, use delete comment mutation. So I'm calling it delete comment, so it's a delete mutation, create mutation, right? And right here they're making the call to my Next.js backend, which is create comment and delete comment. So let's go take a quick look at how they are. Pages API, and let's look at create comment, delete comment. So pretty much these guys make the call, and we check for the post request, at least especially for the create one, and then we just get the JWT cookie from the request header, because now this is at the server end, so we're not really accessing the front end cookie at all, because this is HTTP only cookie. So now with that JWT, we're just saying, oh, if it's not there, then say not authenticated. But if it is there, then we just straight up call the Strapi API client and post to the comment. And since Strapi API know exactly where to go, which is the Strapi backend, and then it will recognize that Strapi has a /comments endpoint where we just put in this data, content, post ID, user ID, etc., and then we give it the authorization JWT token, and that's it. If it is successful, we get a response data, and the rest are just error message handling. Same way, delete is like a little bit simpler. We do the exact same things, and this time we just send a call to the /comment/ID. This time we need an ID because we need to tell the API exactly which comment are we trying to delete, and we just await it and send the result. Once this is successful, we send comment deleted successfully, the rest just error handling. That said, now that we know, we can actually do post, how we can create something and delete something from the backend using Redux. So now let's see what's happening at the front end. So let's go to the create form first. This is the comment form. This is a little bit complicated because I'm using React hook form to create some validation and stuff onto my very simple comment form. It actually has the post button, and this is the text area. Basically this guy right here, and this is the post button. And the important thing is, once we submit the form, see handle submit, on submit, what happens is, this is our on submit function. We just reset the form first, and then we just create comment and pass along the data that we collected from that form. And this create comment comes from use create comment mutation that is API comments gives us. We just take this and we await it, put the data through, and we get a commenting successful. Rest just error message handling. And now let's check out the comment list. This is basically this guy right here. And we make the delete button show up according to authentication. So let's go find that delete button right there. And basically what's happening is handle delete comment, and we pass along the comment ID. And this guy is getting this delete comment function from use delete comment mutation. And then similar way, we're just using the ID dot unwrap, because this is another function given to us by Redux. This helps us turn this whole thing into a regular promise. Take all the Redux mumbo jumbo out, and then if it is successful, we just toast it, comment deleted, and on the like this. Once we delete it, we get a message like that from a toast, and our delete disappears. And that's because of this invalidate tags. This is the most important part. If you have this, you don't need a slice to update the state. See right here, we are adding something to our query is that provides tags, and the type is comment and ID is list. It's just a made up ID, but if you say it here, you have to mention everywhere. So with that provides tag. So after each function here, successful function, we just invalidate tags and pass along this one. So with this, what it does is updates all the comments information inside our store. Automatically does. So for that, we don't need to handle is comment slice separately. Same thing here. As soon as this is deleted, it just takes it out of the equation by invalidating the tag, which is basically refreshing the root state. That's what's happening. And the rest here are just error message handling. Now that we have come this far, at the very last, I just want to show you the pagination part. All right, so this area right here is the blog list component, and this block right here is the pagination component, right? That's what we're going to look at. All right, so blog post list. So this is where we're getting all the posts, and we're collecting the current page from the post filters.current page, and then post per page number from post filters.post per page. And as you know, they're all part of post filter slice, and they will all have their state right here. And then declaring a function on page change. Here we get a new page number, and immediately I'm pushing the cursor all the way to the top of the browser. Otherwise, it just sinks in, goes somewhere else. And then dispatch set current page to the new page number that comes in, which is basically this is the pagination component, and this is right here. On click, one of those pagination buttons. This guys like that. See, it immediately went to the top of the page, and this one got highlighted because on page change, we're giving it like a current page -1. With this change, this one gets up to date, and the current page becomes that new page number. And in here, we call in the pagination component. We send out that current page we just collected from our Redux status, and then a total page count. And this is actually we're getting from post meta pagination total / post per page. And where this is coming from, as we know, in here, the meta always have this pagination and then total count right there. And the rest is just a page size. This is also coming from Redux, and total item count. This is the total, and this is the calculated total page count. So these are going there as a prop, and right here we're declaring the pagination prop, and then pagination. Here we're creating a whole bunch of items like total page count by calculating the total item count divided by page size, and then can go, and this is a boolean. If current page is greater than 1, then this becomes true, and can go next. If current page is smaller than total page count, then this becomes true, so on and so forth. We're calculating the starting item number, ending item number, and then depending on the can go previous, true or false, we show this block, and we turn this total page count into an array and map through it, and that's how we create the page number indexes. And whatever we collect here, we show it there, and lots of it is just styling stuff, right? So don't pay too much attention to that. And then if can go next is okay, then we enable this other portion, and that's in total our pagination component. With that, my friends, we finish our recent blog built with the Next.js, Redux, TypeScript, and Strapi. Thanks for watching.